We have constructed our enemy scene. We have animated our enemy. Let's make the enemy script so that we can move our enemy and also allow it to damage our player. So I'm just going into, so I'm in Robot Crab, my enemy scene, going into script view. And the first thing that we need to do is set up some variables. So the enemy is going to appear in the game. It's going to move a certain number of pixels to the left. It's going to turn around, move a certain number of pixels to the right. And that's how it's going to move throughout the game. It's going to move one way, then the other way. And the player has to jump on it to deactivate it, or the player can just jump over it and carry on. So we need some variables first. And I'm going to first define my export variables, because they are super useful when you're prototyping your game. So I type export var to create an export variable. First thing I need is my speed. So how fast is our enemy going to move in pixels per second? And I'm going to start with 50. Then we need to specify how far it's going to travel before it changes direction. So again, we'll have an export var, and we will call it travel distance. And we'll set that to 100. These are export variables, so we will be able to change them in the inspector just to fine-tune our game. Then we just need to set the direction of travel, and that is going to be +1 or -1, depending on if we're going to go left or right. I'm going to set it first to -1, which will make our player move to the left when it first appears in the game. When the enemy does first appear in the game, it needs to work out for itself how far it can travel to the left and how far it can travel to the right. So it's going to get its position, and it's going to add the travel distance to work out how far it can go to the right, and it's going to subtract the travel distance to work out how far it can go to the left. Then it will have absolute values that it cannot travel beyond. We can then check those values and make it change direction if it is traveling too far to the left or too far to the right. I'm not sure that made any sense, but you will see in a second when we start progressing with our script how it's going to work. So I'm going to define two variables, which is left limit, limit left, and another one which is limit right. And when it appears in the game, it's going to work out what those limits are. If we just go into 2D view, you can see there's a scale at the top and there's a scale on the side. So they sort of form coordinates to enable us to make these calculations, okay? Back into script. All right. So let's crack on with that. So the next thing we need to know is if we're damaging the player, and that's going to be a Boolean. So I'm going to call it variable damaging player. And that's going to equal false because we're not going to be damaging the player when we first appear. Then we need to get the gravity. So I'll just put a little note. You need this hash sign. And I'm just going to write get the gravity. And we get the gravity from the project settings. So we go var gravity equals, and it should autocomplete. It should be project settings dot get setting. They autocomplete quite well. And then we go physics. We supply it as a string, by the way, so we need quotation marks. Physics 2D / default gravity with an underscore. Oh, an underscore. Okay, hopefully that'll work. Now, on the ready function, we have to define how far we can go to the left and how far we can go to the right. So we're going to take our position, our start position, subtract the travel distance for the left and add the travel distance for the right. So how do we go about doing that? Well, we just need to define those variables. So we go limit left equals position dot x. This is a built-in value to the node, so every node knows its position on the screen. And we're going left, so we go minus travel distance, and then we define limit right equals, and you can probably guess it, position dot x plus travel distance. And then our enemy knows how far it can go to the left and how far it can go to the right, and we can check for that and turn it around if it's at risk of going too far. All right, that's our ready function done. Let's crack on. Oh, it's not quite done, because we have to start animating our player. So my indentation's all wrong, so I'll get the cursor there and press it down. My indentation will be right. We want to make our animation player play its animation. Animation player dot play. And what do we call it? Animation player dot play. Move left. There we go. And that is our ready function done. Right, I'm going to change the process function to the physics process. So remember, the physics process, it runs at a predetermined frame rate. So our game is running at 60 frames per second. And that's all we need. So physics process. The process function just keeps running and running. But as we're dealing with player detection, that is handled by the physics engine because it involves collisions. So the physics process is a place to do it. All right. So what we're going to do first is check if we're damaging the player. Damaging the player is a Boolean. So to check if we're damaging the player, we just do if damaging player. If damaging player is the same as saying if damaging player equals true. It's just shorthand. But we don't have to put equals true, because if we just put if damaging player, that's shorthand for equals true. On to the next line. And all I'm going to do is, like we've been doing before, print player being damaged. As I say, I think we'll do the GUI in the next section. So that's the physics process, and we're going to do a bunch more stuff in the physics process. So on every frame, we check if we're damaging the player, and if we are, we do something. All right. Now, the next thing we need to do is check our position, because we will be moving the player. So let's write a function to check our position. We'll come back to the physics process in a sec, because we've got a lot more work to do in the physics process. Func check position. And a colon. First, let's decide. First, let's check if we've moved too far to the left. So we go if position dot x is less than or equal to limit left, colon, direction equals +1. Okay, so that means if we've gone too far to the left, change our direction to +1, and we'll start moving to the right. Opposite thing for if we've gone too far to the right, so if position dot x is greater than or equal to limit right, colon, direction equals -1. But that's not enough. We've got to play our animations, haven't we? So we've got to play an animation depending on if we're moving right or moving left. So new line under there, animation player dot play. And remember, this is if we've gone too far right. So if we've exceeded our limit left, we turn and face the right and we play move right. And then the opposite for turning left. Animation player dot play. So this is if we've exceeded our right limit, so we need to turn back left and we play move left. Okay. That's our check position function finished, but we need to check position on every frame. So in the physics process, we just call that function check position. Okay, now let's talk about player movement. And the easiest plane to move in to start with is up and down, okay? And it's very easy in our enemy. Our enemy is going to be on the ground, apart from if there is no ground, in which case it's going to fall under gravity, which is why we put gravity in. So first we check if we're on the ground or not. And we have a built-in function to do that, and it's called isOnFloor. So we just go if. So we go if not is on floor, it's that one. And we're looking at our movement in the up and down direction. In the up and down direction. So that is movement dot y. That's the y-axis. So we go velocity dot y plus equals gravity plus delta. Delta is the elapsed time between frames. So it means the game should run fairly consistently on different specifications of computer. Okay, it shouldn't be too much of a difference. So that's the point of it. It smooths out the differences between slower moving and faster moving computers by adding the elapsed time between frames, in this case to our velocity. Okay, so the more elapsed time between frames, the bigger delta is, the more you move between frames, and that compensates for your computer moving, running more slowly. All right, so it's velocity.y equals gravity times plus delta. So what about velocity.x? We go velocity.x. So that's movement in our this way. Velocity.x equals direction, which we've already defined, times speed. But that's not all, because we've actually still got to tell it to move, and Godot provides us a useful function to make us move, and that function is called move and slide. All right. Should we test that out? Let's test it out. I'm going to go Control save to save it. Go into our level template, 2D view, shrink that a bit. I'm going to delete this robot grab because I've changed it. It should work, but it's just going to instance in a new one. So into robot grab, save. Into level template, instance in robot crab. It's going to be up there, so I'll move it. And let's play the scene, see how it works. Our robot moves, it changes direction, goes 100 pixels, changes direction. Okay, it seems to be picking something up, which isn't the player, when it bumps into the walls. So let's see if we can fix that next.